Hi, welcome to our mini lectures on pre-calculus. Today's topic is word problem involving a sine or cosine function, problem type 1. Okay, we are talking about something called simple harmonic motion that would be similar to the movement of, say, a spring uh, to which like you have a spring like this and a mass perhaps is attached to it. At the top it is anchored to ceiling or something. You let it come through to rest, and then you perhaps pull it down or press it up, and then it goes through an oscillation. We are going to consider the ideal oscillation, that it doesn't die out and has a simple structure. We can describe it with sine or cosine functions, and here we are looking at the simplest example of it. So we are looking at a movement that can be described as a times sine of bt. You remember a was called amplitude in absolute value. If we take our vertical axis to go upward, typically that's what we do, and then a will be positive, otherwise a will be negative. We are always taking to b to be positive. B divided by 2 pi, if you remember, that was the number of cycles per unit of time, and 2 pi divided by b, that was the period of oscillation. That's the length of time it takes for one complete movement. So if I start from the middle, like if I go up, come back down, and come back to the same as initial location, that is going to be considered one period. So going up, coming down, and coming back to the original location, that is one period. The length of that period is 2 pi over b. You remember that in general this was a sine of bt plus c plus d. Those more general cases can also be used in similar problems. Okay, let's go look at the simplest type of problems of this type. This is a floating object in the sea is bobbing in a simple harmonic motion. So that's our clue that this is a simple harmonic motion with an amplitude of 9 inches. So absolute value of A is 9 inches. We are given that the period of this is 0.2 seconds. So let's write y is equal to, say, a sine of bt. So a absolute value of a is 9, period, which was 2 pi over b. So when this becomes 2 pi, we are repeating all over again. So that means the length of time it takes for us to go through that is the period, which is going to be 2 pi over b. So what does this mean? It means b is 2 pi over 0.2. Now, we are also said that it is initially moving upward. So if it is initially moving upward, means a is 9 as opposed to be minus 9. Instead of y, letter d is used here, not to be confused with the d that we had for the midline previously. So that's d here means the distance, and our final answer is going to become 9 sine of 2 pi over 0.2 t. We write it a bit nicer, so sine of this becomes 10 pi t, and that is good enough of an answer. Similar problem, an object moves in simple harmonic motion with amplitude of 9 meters and period of 3 minutes. At time equal to 0 minutes, its displacement d from the rest is 0. That means we don't have any shift or anything, and it initially moves in the positive direction, so it's going up first. So again, we are going to use y is equal to a sine of bt, A in absolute value is 9, and since we are moving in a positive direction, A is going to be chosen to be 9. The period of this thing is 3 minutes, so period P is 2 pi over B, and that's supposed to be 3 minutes. Unit of time is not specified what unit we are going to use as time, so we are just going to use whatever was given here. So B is going to be 3 divided by 2 pi. Let me see if I make a mistake here. Excuse me, I made a mistake here. Strange. So B is 2 pi third. Sorry for that mistake. And then we are all done. So this is 9 sine of 2 pi third t. That is final answer. Similarly, here we have a buoy floating in the sea, and it has an amplitude of 12 inches, a period of half a second, and at time 0 it's at location 0, and it's moving downward. Downward is taken to be negative, so y is equal to a sine of bt. Again, absolute value of a is 12 inches, but since we are going to go down, a will be minus 12. That's the only difference here. Period is 2 pi over b, and that is given to be half a second. So b is 2 pi over 2 pi over 0.5, so that becomes 4 pi. So a d, we said so the y, we are using letter d for distance. This is going to be minus 12 sine of 4 pi t. So that covers the simplest type of these, problem type 1. And if we have type 2 and 3, we can take care of that as well. So again, we have one application of sine or cosine. So we are going to see this thing in physics, in engineering, calculus very often. Simplest example is a weight dangling from a spring going through oscillatory motion. So sometimes this is called simple harmonic oscillation. So SHO instead of SHM. We are looking at the ideal case where there is no friction or damping, so the amplitude doesn't go down, it just stays as a perfect wave forever. In future classes, you're going to look at the situations where we do have some damping effect, and so the oscillations go kind of like this, kind of a thing that you see in either doctor movies or old-time science fiction movies. They always had some kind of a curve like this on some screen. Okay, this is a short lecture, and we are going to see again for the next topic. Until then, good luck and God bless.